I'm Danny Hermes. I'm going to be talking about a little project of mine called tailsk8s. As you can see here from these two logos, it's a combination of Tailscale, the mesh VPN, and Kubernetes. I'm not going to go into too much detail into what either of those things are. Feel free to read about them on the internet. But what I'm going to do here is I'm going to run a bare metal Kubernetes cluster and use Tailscale as the underlying network. So I'm here on my jump host, the machine I'm going to be using to orchestrate all of the nodes in the cluster and the devices in my Tailscale tailnet. So first, let me talk about what I did to bring this machine up to speed. So some prerequisites here. I've got SSH installed so I can connect to each of the machines. I've got Tailscale installed. I'm on the tailnet so I can reach machines over Tailscale. I've got kubectl so I can administer my clusters directly from this machine. And then later on, in addition to bare metal, we'll be doing things with Google Cloud and AWS. So I've got clients ready to go there. And we can actually see I've got an AWS Vault subshell here. There's my profile name, dhermes. To get it configured, I ran Tailscale up and I configured the AWS and Google Cloud clients. Also, I've got a file here called extra authorized keys, which has all of the keys that I'll need. Which will allow me to SSH into any of my machines. I'll get this added, we'll see here in a moment, to these remote machines as part of bootstrapping so that I can connect in. Additionally, there's some files in k8s Bootstrap shared, which will allow me to communicate with the Tailscale API. So let's see a little bit more about where I got those. These are just screenshots. I don't really want to expose my account in real time on Tailscale. So on my account, and I recommend on everybody's account, I've got device authorization turned on. So all new devices need to be manually authorized. However, Tailscale does have an API. So the API allows authorization of new devices, as well as some other actions that we're going to be taking today. So I went and got an API key. That's one of those files we saw in that directory. Additionally, I've got 6 one-off keys. These are because we're going to have 4 bare metal devices that I'll be having joined from my home and 2 cloud devices. So a one-off key can only be used one time, and the moment it gets used for the machine to join the tailnet, it can no longer be reused. So after adding, this is what it would look like in the account. So before I dive into actually doing anything, I want to give a shout, give a description of the actual home lab that we're going to be working with. So this is the jump host that I'm recording on right now. This is a laptop I bought within the last year. It's an Asus. It's running Windows. I'm on Linux, Windows subsystem for Linux. It's mostly a great experience, though some hiccups here and there, or really just stuff that requires a little extra work out of me. Next is not actually a machine, but it's the name of the cluster. So for all of the machines, including this one I'm on, has a name, Suspicious Hawking, named after Stephen Hawking, the physicist. I use the Moby or Docker random name generator, just seeding the random generator with the current time. And I got Rob Pike. So the actual cluster name is Stoic Pike. And here's a picture of Rob Pike being somewhat stoic. So for those who don't know, Rob Pike is one of the 3 creators of the Go programming language. And the Go programming language is incredibly influential in this system space that we're in, both influencing Kubernetes, Docker, and Tailscale. So pretty fitting that Rob Pike is one of the generated names for the entire cluster. The first machine is actually underneath this bed right behind me in my office. This is Pedantic Yonats. You can see here it's the power block for a Mac, and this is a early 2011 MacBook. However, since it's Apple hardware, it's in pretty good shape. This is the highest grade of the 4 machines in this little home lab. I just found these machines lying around over Thanksgiving and wanted to do something fun with them. And so that's how this came about. The next one's called Eager Jennings. This is the second highest powered machine. So along with Pedantic Yonat, it will be a control plane node. Instead of under a bed in the office, it's under a dresser in a bedroom. It's a PC, and it's a 2017-ish machine. Next one, not under a bed, not under a dresser, but under a chair. This is nice McClintock. This is a 2014 PC. This one has some spottiness with the Wi-Fi radio, so it's directly connected into the modem. It is also going to serve as our load balancer. I wish I had more machines, but it's going to be a worker node and a load balancer. The last physical machine in the house is Relax Bauman. This is literally the last tower I ever bought. I bought this in 2011 on Black Friday. I don't even know if Cyber Monday was a thing in 2011. I bought it on Tiger Direct. I have not booted it for 5 years, but it's back running Ubuntu 20 now and not complaining at all about running Kubernetes and Tailscale. After the machines that I own, the next thing will be my other computer is a data center. So we're going to have a control plane node called Interesting Zhang in AWS and a worker node called Agitated Faisal in Google Cloud Platform. And the great thing about Tailscale is we don't need any virtual networking provided by the clouds themselves. We're going to do all of the networking virtualization via Tailscale. And these 4 machines that I can physically walk up to and touch are going to be on the same footing as these 2 machines in 2 different clouds. So this gives us, a nice mix of bare metal and very, very far from bare metal. So the cast of players, again, all put together. Nice McClintock is doing double duty as a load balancer and a worker node. My 3 control plane nodes are Pedantic Yonat, that MacBook, Eager Jennings, and the AWS Interesting Zhang. And the workers are nice McClintock, Relax Bauman, that tower, and the GCP Agitated Faisal. So the next thing from here, I want to show how to bring up one of these machines. So I'm going to switch from my jump host for a moment and show you what it looks like when one of these new machines comes alive. So I'm going to flash it from a thumb drive and install Ubuntu Fresh on it, and then I need to do a minimal amount of bootstrap to be able to SSH into it.
Okay, here we are on Eager Jennings. The goal here is to do the minimum amount of things necessary to allow the jump host to SSH in here. So the first thing we want to do is make sure we've got up-to-date package lists from all of our apt repositories, and then we want to just install a few things. So essentially we just need SSH, but I'm also going to make sure netcat is installed because we're going to just do a raw TCP listener with netcat to copy a file over the network. So I'm going to use netcat to copy into this machine from the jump host. Okay, great. So we got SSH ready to go. The next thing I want to do is I want to make sure that my SSH config does not allow password auth. So we can find the password auth line and make sure it says no. So it is not enabled or disabled by default, so it uses the default value, which is to make it enabled. So we don't want password auth. Once we've disabled password auth, we're going to restart the SSH service. So the primary reason we want this is just we want SSH only via keys, having access to private keys. Okay, great. So now I want to be able to reach this thing from the jump host, so I need to figure out what the address is on the local network. What did I spell wrong? Addresses. Doesn't have 2 S's at the end. There we go. So 192.168.7.75 is the address of this machine on the local network. So what I will do is I will set up a netcat listener. I'll listen on port 9107. I'll make sure to broadcast to the whole network, and then I'll just store this in extra authorized keys. I don't want to put it directly in my SSH keys just yet because I want to make sure everything looks good. Okay, great. So now I have that listener. Now I can hop over my jump host and send the keys over port 9107. And now they've arrived. Let's see. Great. So they've arrived. So for context, the command I ran on my jump host, I was in the working directory for tailsk8s. I catted the extra authorized keys file, and I piped it to netcat. I just said quit after 1 second, and then I hit up the IP locally of this machine, as well as the port. That's all I did. Okay, so this public key is what we wanted. So let's see what we got going on here. Okay, nothing. Great. We'll just move that file to authorized keys here. And the permissions are good on authorized keys. Great. So we should be able to SSH in now as the suspicious hawking user. I will quickly hop over to my jump host and make sure that's true. Let's see. I tried to connect directly to Eager Jennings. That host name is no good because we're not on the tailnet yet. Let me SSH in over the IP directly. Okay, I'm in. And just for fun, I'll add a file here so we can see there are no text files. So from the other host, I'll just make a hello.txt file. Oopsie. And now that hello.txt file is there, it's an empty file, but it exists. And that's that. So from here, we can head back to the jump host and continue bootstrapping this machine so that it can be ready to become a Kubernetes node.
Okay, so now we've got SSH access from the jump host, so we can confirm that we can reach this new machine, Eager Jennings, from the jump host. Great. So now we can do that. Let's copy over some files that we're going to need to actually finish bringing the machine up. So the first, we're going to have a tailscale one-off key that we can use to auth into the tailnet, and the other is a script that we're going to get going as quick as we can here. Great, so we got those copied over. Let's SSH back in and get the script running. So the script just takes a single argument, and that argument is going to be that one-off key that we copied over. So let's let that run, and let's take a look at the script. So the script, like we said, takes a single argument. There's going to be a bootstrap directory that we get set up here. First thing, it installs basic set of dependencies just so we can add custom app repositories for Tailscale and Docker. Then make sure all packages are up to date. Uninstalls anything hanging around for Docker. On a fresh Ubuntu install, this shouldn't be an issue. And then installs things needed for kube networking, things needed for Docker, Tailscale, uncomplicated firewall, etc. Make sure that the time zone is set to UTC, sets up our bootstrap directory, sets up some custom networking configuration for Tailscale, and then joins the tailnet. At this point, it would be either we could, through the UI, authorize this machine, or there's a binary in this project for authorizing. I'm going to use the Windows variant. Since I'm on Windows subsystem for Linux, I can use Windows or Linux variants of scripts. And since I've got the Tailscale daemon running on the Windows side of this house on this machine, it makes more sense for me to use the Windows variant of this binary. So we can see here the flags I want. I'm going to use debug mode so we can see a little bit more information. My API key is in this directory. And then this hostname we just added is Eager Jennings. This should work just fine for us. Great. And so we can see here we authorized this device in the Tailscale API. And then over here, the script has continued on with this last piece, which is to enable UFW, uncomplicated firewall, so that the only traffic in or out of the machine is via tailscale. And so that setup is complete. So I can remove the files I used here. That one-off key has already been removed by new machine.sh. Wonderful. So now if I try to connect over a non-tailscale connection just over the network, we should see it time out fairly quickly here. So let's see. After 5 seconds, does it connect? No, it does not. Whereas if I connect over the tailscale name of the machine, so make sure this connection goes over tailscale, should work just fine. Since this machine has already existed before, let me clear it. Great. So now connected over tailscale, I'm good to go. Great. So that's how I'm going to bring up a new machine. There are 3 other machines that I need to do this to. So let me hop off real quick and do that. And then we can start the process of actually bringing our cluster online. Okay. So after all of the machines have the basic set of dependencies installed on them, the next thing to do is to prepare them for Kubernetes. So essentially just need to add a couple pieces of configuration, install a couple Kubernetes binaries. So the first thing I'm going to do is I'm going to move a script called k8s-install.sh onto each of the machines. Let me switch over here so we can look at it for a moment. This freezes, it pins to specific versions of a lot of these binaries. It sets systemd as the C group driver for Docker, restarts Docker, uses sysctl to set a couple Kubernetes specific settings and load a Kubernetes specific filter via modprobe, downloads kubectl, kubeadmin, kubelet, etc., and does a few other things, right? Additionally, it'll prefetch the images needed by kubeadmin. So I'm just gonna copy this thing over to each of my machines. So first I'm going to do it to Pedantic Yonat, and then we'll get the process going here. And while we're waiting, we'll copy it over to some of these other machines as well. Okay, got it copied over, and we'll start running it. We're going to run that script, and now I'll start copying it over to some of these other machines while this runs. Okay, let's see. Eager Jennings. Nice McClintock. Yeah, it takes a bit of time to download some of these things. I probably could have just checked it into the repo or cached it locally, but this makes sure we're pulling the latest and greatest. All right, so that leaves us ready to go on Pedantic Yonat. So you'd think maybe the next step is to bring up the cluster. Not quite. So before we can bring up the cluster, we need a way to represent the Kube API, the control plane, as a single addressable object. Usually this would be handled by some cloud provided load balancer, either traditional elastic load balancer or a more modern application load balancer. Chances are it would be an L4 load balancer because Kube handles TLS for itself, unless you do a little extra work. But either way, we're not in the cloud, so we're going to have to do this ourselves. We're going to do this via the recommendations from the kubeadmin project and just run HA proxy on one of our nodes. So that's going to be nice McClintock. So luckily we've got another script for doing this, load balancer proxy.sh. I'm going to copy this onto nice McClintock. We'll take a look at it in a sec. Let's see, hope I spelled everything correctly. We'll hop on a nice McClintock. But I want to get the Kube install script running on nice McClintock as well. I'll get it running on Relax Bauman before I forget, and then we'll take a look at that script. Okay, so Kate's load balancer proxy. Okay, so what does this thing do? So it takes a variable number of tailscale host names, and we'll see in a sec that it uses the tailscale status to actually associate those host names with an IP address, a tailscale IP address. Installs HA proxy, keeps track of the IP of the current device in the tailscale network, makes sure it can bind to IP addresses that are maybe not associated with the local machine, depending on how tailscale is messing with local configurations. It uses essentially the same config recommended in the kubeadmin docs, where the only thing unique here is we're iterating through the arguments to this script, and for each host, we're grepping for the host name in tailscale status. This is very inexact. For example, if you have host names that collide, this script will break down. Not intended to be production grade here. And then after writing the configuration file, make sure that the HA proxy unit is enabled with systemd, and then restarting it to make sure that the config gets reloaded. So that's all that's happening there. Going to actually run this here. So I've got k8s install already done on Nice McClintock and done on Relax Bauman. Let me get it going on this last machine, Eager Jennings, which I left out. Okay, so now let's bring up this load balancer here on Nice McClintock. For now, Pedantic Yonat is the fanciest machine in the network, so that's going to be my only control plane node. So that's the only machine I will feed to this script. So this is going to take a little extra time because it's got to actually install some packages from various apt repos. Okay, great. So unsurprisingly, the backend is not available because we haven't done anything at Pedantic Yonat yet. Just as a sanity check, so this IP here, let me show you tailscale IP. So that's the IP of this current machine, and 6443 is the Kube API server port. So we just want to make sure that that our load balancer is running, even if it's not actually able to reach the underlying servers that it's load balancing for. Okay, great. So, all right, back to Pedantic Yonat. So now that we have a load balancer, it's time to actually bring up the cluster. So I've got another script for this. This is called, I think, primary init. So I'll get that over on Pedantic Yonat. This script actually has a couple dependencies. So one dependency is a custom tailscale advertise script. I'm going to go in pretty great detail about what that does in a bit. So we're going to copy both of those over. In addition to that, we need some configuration. So I've already got this in my shell history. So we need a kubeadmin config file, and we'll look at what that does in a bit. That's a template file. And we also need the tailscale API key. When we invoke this advertise binary, we actually need to talk to the tailscale API. So we'll get both of these copied over. Let's make our way onto Pedantic Yonat. First thing I'm going to do is move this tailscale binary onto my path via just the short name for it, tailscale advertise. Okay, also I want to talk briefly about this bootstrap directory. So right now there's just the two files that we put in there. But the idea is when I run this script, I'll get rid of the script we already ran. When I run this primary init script, I'm going to populate a bunch of data in this bootstrap directory so I can lift it back onto my jump host so I can reuse it from other places. So we'll see in a bit why that's a good idea, but this is going to be the stash that I'll use on every node. So, all right, let's take a look at this primary init script. I'm not going to go in great detail. It'll be in the repo for this video. The repo will be linked to in the video, so feel free to look at it at your own speed if need be. So this script has 5 inputs. The first is the cluster name, that's Stoke Pike that we said. Next is the pod subnet. This is a global subnet of addresses, IP addresses that can be used for any pod in the entire cluster. Service subnet, exactly the same idea except for services. The advertised subnet is a bit unique to the way we're doing this. So many kube CNIs do not have a distinction for which node a pod came from in how the IPs are getting assigned. This one, we're using host local addressing along with tailscale tailscale subnet routers. So so the advertised subnet is unique. It's a portion of the pod subnet that is going to be handled directly by this node. And so this is going to be true for every node that we put in the cluster. It just so happens to also be true for the very first node, which is also bringing up the entire cluster, handling cluster-wide configuration that only has to be done once. And then the last piece is the address of our load balancer. We could use a DNS name here, but I don't want to rely on magic DNS components of Tailscale here. So we're just going to use the Tailscale IP for the address, but it really could be any address for the load balancer. So what does the script do? Does some validation. It generates a join token. So kubeadmin, new nodes need to present a join token to authenticate with the existing cluster. Our certificate key is used for encrypting and decrypting private keys for the kube root CA, for the etcd root CA, and a couple other CAs. This is a nice feature, or the certificate key feature of kubeadmin. I had previously tried to copy around the right subset of CA files and private keys just via SCP or NFS, and I kept screwing it up. So I'm very happy that I can just let kubeadmin do it for me. That's kind of the point here. The next thing we put in there is just the control plane load balancer. This is an input to the script. I just don't want to have it be an input to every subsequent script, so we're keeping it around in this bootstrap directory. The very first thing we do is set up the CNI. I'm not going to go into much detail about this yet. I want to get the cluster going, and then we'll rewind the clock and talk a bit more about the CNI. But essentially, host local is using the simplest CNI possible. It's the same thing that Kelsey Hightower does in Kubernetes the hard way, yet we have some tailscale flavor to it. Next thing we do, again, I'll come back to this, is we advertise our particular subnet to the rest of the tailnet. Then we populate our template file. We'll look at that template file in a moment. Then we run kubeadmin init and do some various cleanup. So some of the pieces of cleanup, we are keeping around a certificate hash from a newly generated CA certificate for the kube root CA, and then also the newly generated kube config. We are putting in our bootstrap directory. So, for example, I can interact with the cluster directly from the jump host and interact with it from some of the new nodes. So before we actually bring up the cluster, let's for a moment look at this template, kubeadmin, there we go, init config. So this is 3 particular resources. These are not really kube resources. They're like kube resources, but they specify this is essentially, a more than just what the flags provide to the kubeadmin init command. So obviously we need a join token, one that we specify and can track outside of this command. We're telling Kube API server what its address should be for the local node. This is for the encryption of the CAs. This one is a really important one. Kubelet by default won't know whether it should use the tailscale IP or should use just some local IP, like a 192.168 IP on the local network. And so this is a way to explicitly tell kubelet what to use. So you can see here, host IP, this argument in the script is actually being set to the tailscale IP of the current node. We've got these cluster-wide settings like the cluster name and the service and pod subnet, as well as how to reach the control plane. And then this last piece, systemd is managing C groups. So we already knew that. We already told Docker that. Great. So let's bring this cluster up. So first thing is cluster name, Stovepike. Next thing is the pod subnet. So a quick note here about the pod subnet. So if you look here at my tailscale IP, it's a 100 dot IP. Same thing for the IP on my jump host. You name it, they're 100 dot IPs. So these are in the so-called CG-NAT address space. CG meaning carrier gateway, and Tailscale guarantees that's where Tailscale IPs will be. So we avoid colliding with this. For these purposes, I'm just going to use the 10 dot address space. This is the so-called 24-bit block of the RFC 1918 private address spaces. So 10.100 is what we're going to use for pods. 10.101 is what we're going to use for services. The next piece is we need to carve out a portion of 10.100 just for this particular node. So I'm just using a /24 as a portion of that /16. And then the last piece is the IP address of the load balancer, which I have forgotten, but we'll just grab that from tailscale status and we'll prep for the load balancer's name. So it's 100.70.213.118. Okay, so we should be able to bring this up and not be too sad. So you can see here interactions with the Tailscale API. Again, we'll backpedal, rewind after the cluster is up, and talk a bit more about that in greater detail. Okay, hopefully the control plane comes up fairly quick. All right, looks like we're just about done here. Okay, there we go. The command succeeded. We're going to get rid of that script. Before I forget, I want to lift. Some of these new Bootstrap files onto the jump host so that we can push them back. I'm going to copy paste the command I've got stored up, ready to go. Okay, so I've got a set of files that I know I want to keep here that are new. So I've got the CA cert hash, the certificate key, control plane load balancer, the join token, and my kube config. And I'm going to copy them from dhermes at pedantic yonat. Let's see. All right. And then I want to copy them into this Bootstrap directory here. Great. Okay. So I should be able to use kubectl directly from the jump host to interact with Kube API. Great. 75 seconds since the cluster came into existence, and I should also be able to do it directly from the cluster itself. So kubectl get nodes, all good there. If I go for a wide output, then we can see my internal IP is that tailscale IP for this node. Similarly, you can look at some of the pods that are running. We'll go in all namespaces. And screen width isn't our friend here, but you can see the two core DNS pods are actually in the address space for this node, and everything else, these are using the node's IP directly. So like etcd, Kube API server, etc. Okay, great. So our next task is to complete the control plane, or at least complete the bare metal part of the control plane, and bring up our next control plane server. So that's going to be Eager Jennings. I've got another script here. Actually, sorry, before I do that, I did promise that I would talk about the CNI portion of things. So let me zoom back out and talk about that. So okay, cool. So what is happening in the CNI portion of things? So there's not much to see here. This uses the KubeNet CNI. It essentially ships with Kubernetes. It's very bare bones. It's intentionally very bare bones. We're just saying that I'm letting the host handle this, and I'll tell you the subnet that I should be managing, and that'll get broadcast to the rest of Kubernetes. That doesn't help with the actual backbone network that they're on, which is why in cloud providers you need to manually specify routes. But here we're doing that with Tailscale. So this is where the manually specify with routes comes in. So using Tailscale advertise, it's a binary that's in this repo where all the other configs are. So what does that amount to? So I'm going to run it again. I'm not sure if I'll get everything quite right here. Let me run the help. I don't need sudo for help. Okay, great. Okay, so I'm going to run it in debug mode. My API key will be in this bootstrap directory. And then my CIDR is going to be the CIDR that we declared for this node. So by running this in debug mode, I can actually see what the script is doing. So let me zoom out, or let me go step by step and talk about what it's doing. So the first thing it's doing is it's trying to figure out my tailnet. So tailnet is actually one of the arguments here, but I didn't provide it because it can be inferred, right? So the magic DNS suffix for my entire tailnet is included if I just hit if I hit tailscale, the tailscale daemon via the local API, and so I can infer my tailnet is called dhermis.github. Believe it or not, I'm just signed in with my GitHub user, which is dhermis. Next thing I'm doing is I'm getting the configured preferences again via tailscale D. Essentially, I want to see if I've already advertised the CIDR to the net or not, and of course, it's already been accepted and advertised. Next thing I'm doing is I'm figuring out my host name. I'm using my host name to figure out from the set of devices. This is the public tailscale API, and I'm trying to actually see, okay, which one has a host name matching my host name. So this is how I found the actual device, and then from there I can actually check the routes configured for this device and make sure that my advertised route has been enabled there. So the way this gets enabled, let's pull this up for a moment. Preview, please. Yeah, exactly. I've got some screenshots in here that are going to be helpful for us. So the way this gets enabled, by default, once it's advertised, it is not enabled. It needs to be reviewed and enabled by a tailnet admin. The local changes that we first made are essentially equivalent to doing this, tailscale up with a couple flags. So if we were to review the routes, we could see it's not enabled, and then we can click enable, and that's equivalent to what was happening with api.tailscale.com. I did mention if we were in a public cloud, we would have to do this in a different way when using host local addressing. So the way it happens in Kelsey's Kubernetes the hard way is there's a manual creation of routes for each of the nodes. And similarly in the AWS flavored Kubernetes the hard way, is essentially the exact same thing, adding routes to a route table for the given instance and the given block or subnet that the instance is in charge of. I also want to mention, this is a little bit out of order here, but if in a bit we're going to run a smoke test and we're going to bring up a deployment just running HTTP bin. And so if you invoke the /headers route in HTTP bin, it'll just tell you the request headers that it received. So when everything is peachy in tailsk8s in a Kubernetes cluster using Tailscale with subnet advertisement and all that good stuff, everything works just fine. From pedantic Yonat, I can hit nice McClintock, which is a different node, and everything works just fine. But if we were to withdraw the routes, so there's a script called tailscale withdraw, which is the twin to tailscale advertise. If we were to withdraw the routes for nice McClintock and then try to hit it again, then after it was withdrawn, there's no knowledge essentially of the subnet that nice McClintock used to be in charge of, and the request will just time out. It'll get black holed. Cool. So anyway, back to getting the cluster brought up. So the next node that I want to bring up is Eager Jennings. So for Eager Jennings, we actually have quite a bit more files to get on the machine. So just regular scripts. We've got a script, k8s control plane join.sh, essentially like the one we just saw, though it is slightly different. And then I want to do this to dhermis at Eager Jennings. That's the other control plane node. And then we've also got to bring over all of these k8s bootstrap files that we kept around, as well as a template. And let's hop over and look at want to get these in the bootstrap directory. Great. So let's look at the script and then the template, just to get a sense of what's going on here. Okay. So k8s, what is it? Cluster control. There we go. Control plane join. And then kubeadmin control plane join. Great. So this script only has one argument. That argument is just the subnet that the node is in charge of. Here we're just making sure everything is in our bootstrap directory and loading it up. We're setting up the kube config that we've already got from our bootstrap, doing the same CNI dance and advertise dance that we did before. We're using our kubeadmin config template to get populated, and then we just call kubeadmin join. One thing I didn't mention that we're going to do on every node is use a label to keep track of the subnet, because it's not really a real CNI. If you were going to productionize the CNI, you'd probably do something like this with a database, and have a daemon set running, or maybe just a deployment running. But you'd have something that's actually alive and able to keep track of these things, rather than just making best effort with labels and things like this. So we don't need 3 resources. We just need a single one. Join configuration. A lot of the things look the same. One thing that's different is we actually need to verify the hash, so that when we actually are presented with the kube root CA, it's at least correct up to hash collision. And most of these other ones are similar. These are both these are fields we've seen before, but not in the control plane section. It's just been moved from init configuration to a subfield of join configuration. Cool. So on Eager Jennings, let's get everything moving. I'm going to put the script on my path. User local bin, tailscale, advertise. And then we should be in business. So the subnet we're going to use here, we're just going to keep marching them forward. So just increment by 1. So hopefully I don't lose track of how many I've run. So there's this tailscale advertise dance. Wait until that comes back. Now we're joining via kubeadmin. And should be done fairly soon. No, I have forgotten the control plane. Yeah, exactly. The control plane does not know about us. So I need to rerun this, and I need to actually register Eager Jennings, and then we'll be good. I deleted the file. Oh, great. So that took a little longer because the control plane couldn't find this new node, but luckily all was well. Either way, we want to add it to the control plane. Great. So we should be good. We should see 2 nodes now. Same thing here. If I run it from the jump host, I should see 2 nodes. Great. We're good to go. So our control plane is done. So on to the next. We're going to do the worker. Actually, let me, before I forget, erase that that install script. Okay, great. So the next thing is bringing up the workers. So there are going to be 2 workers. Nice McClintock, which is also the load balancer, and then there's going to be, then we're going to move on to the cloud after that. Okay, similar story from before. We've got to copy over this tailscale advertise and a script. So we'll get over to nice McClintock, and at the same time, I'm going to get it over to relaxed Bauman. And then we're also going to copy over a bunch of configuration. Hermes at nice McClintock. Oopsie. And we're going to get that in our bootstrap directory. All right, here, get it over to relaxed Bauman. Again, in the bootstrap directory. Oopsie. Left out a colon. Okay, great. All right, so let's hop on to each of these machines. So, nice McClintock. Oopsie. Hermes at Relax Bauman. On both of these machines, I'm gonna get the tailscale advertise script installed. User local bin, tailscale advertise. All right. And then before actually executing these commands, so that the install script or the join script, just like for the control plane. What else is on here? The load balancer. Yes. Kate's worker join. So the subnet we'll use here, we're going to keep marching in the 10.100 /16. So we're going to add a /24 at 2. And here we're going to do it at 3. But let's review these scripts before we run it. .3. All right. Worker join. And I've got a variant of the control plane join that's just worker join. Not going to say much about it other than they are essentially identical. The only difference is the control plane section is missing in the worker. That's literally the only difference. Why is it missing? Because it's not a control plane node. So that's pretty straightforward. Essentially everything else here is the same, except we don't need to deal with the certificate key like we did for the control plane nodes, because we don't have to decrypt the private keys, because we don't need to do anything with the CAs because we're not the control plane. There's CNI stuff, kubeadmin join, label the node. Pretty vanilla. We've seen it before. Great. So let's run it, and then our tailsk8s bare metal cluster will be complete, and it'll be time to smoke test the thing. So for our smoke test, we're going to bring up that HTTP bin deployment. While we wait here, I'll pull it up. So it is deployment. It's a manifest. It has a namespace, a service account, which we really don't need, but it's got one anyway. The deployment, it's running a pinned Docker image for the HTTP bin Docker container, and then I have an anti-affinity rule in here so that, if possible, pods can land on different worker nodes. And then also going to put a standard cluster IP service in front of this. There's been no mention of Metal LB or anything like that in this cluster. That's a story for another day, but we are going to have a basic kube service. So should be good to go. Get rid of this worker join script because we used it. I don't need to be on both of these nodes. I don't actually need to be on either of these nodes. I'm going to go on pedantic Yonat and check some things out. So first of all, let's make sure all our nodes are present. Make sure that the IPs for our nodes are the tailscale IPs. Everything looks good. So now to smoke test, we're going to actually bring up this HTTP bin deployment. Okay, so it's in templates, HTTP bin. Okay, now we can pull the namespace and just wait until the pods come up. For these purposes, I want the pod IPs directly. I believe it was much faster on Nice McClintock because it already had the Docker image and we had to pull it on Relax Bauman, but who knows? In the meantime, let's see if the service is up. Okay, so the service is up. We've got a cluster IP in this 10.101 block. Still waiting. You can do it, Relax Bauman. I believe in you. So the service should still, though it's only got 2 of the 3 pods, great. It's got 3 pods. So we're good to go. So just for good measure, I wanted to hit each of these. So I'm going to hit each pod and make sure networking checks out. And I'm also going to hit the service. So essentially, all of this magic is happening locally via IP tables, and then with a little extra magic from Tailscale. So hitting these IPs these are parts of advertised subnets that Tailscale knows about. And then this IP is virtual, and this will just get routed to Kube proxy, and then Kube proxy will sort out where to actually send the request. So let me first hit the service. So I'll grab this service IP. I'm exposing port 8000, as we can see on the service, and I just want to hit headers. Okay, great, all good. Next thing I want to do is hit the pods. I'm just going to hit one of the pods because, well, actually, I'll hit 1 pod on each node here. So no issues hitting it on Nice McClintock, no issues hitting it on Relax Bauman. So let me do the same thing from the jump host and show that it's slightly different. So again, due to tailscale routing, I can hit the pod directly because my jump host is in the tailnet. The same is true for Nice McClintock and Relax Bauman. But if I try to hit the service, let's let this time out after, let's say, 3 seconds, it's not going to go anywhere, right? And the reason it doesn't go anywhere is because my jump host is not in the cluster, and so the 10.101 address space means nothing. And I haven't done anything to tell Tailscale about the 10.101 subnet either, so it's just a black hole, right? And again, the only reason it works in Kube is because Kube is virtualizing that subnet and actually deferring it to, we'll see here in a sec. It's referring it to the Kube proxy daemon set pod that's actually going to be on whatever node that we're currently on. So one last thing to smoke test, making sure everything is good. I want to actually hit my Kube DNS service. So let's see that bad boy. Is it in Kube system? It is. Great. So there's my IP. So if I run an NS lookup for, let's say, HTTP bin, I'm going to give the full address because I don't think my resolve.conf has these added. Okay, so it resolves the service as expected. So if we were in a pod, then Kube DNS would be in good shape as well. Let me confirm here. Yeah, so you can see here, the only search path I have here is the magic DNS from Tailscale. And so if I had just typed HTTP bin or HTTP bin.http bin, then it wouldn't have completed it from the search path. So that's why I had to do the full search path. Great. So I'm going to clean up HTTP bin by just deleting the entire manifest, and then we're going to move on to the cloud. So that's tailsk8s in a nutshell. Got 4 bare metal machines, each controlling a chunk of the pod subnet, and Tailscale completely handling the routing to make sure the packets end up in the right place. The API we have essentially looks exactly the same as a cloud provider API for subnet routes, and so the next logical step is to integrate with a cloud provider. So we're going to be adding an AWS EC2 and a GCP Compute Engine instance into our cluster, and we're going to see that they look exactly the same as the bare metal machines. So stay tuned for the next video.